So what is the difference between a struct and a class? All right, so classes support methods and have constructors, those kind of things. Structs effectively just support fields. They're not called fields with structs, they're just, but whatever, that's what they support. So a struct has just variable value pairs, where a class has variable value pairs plus a constructor, plus so that you can conveniently build one, plus some potentially other functions that might operate on those things, right? All right. Then can you accomplish the concept of a struct in Java in a Java program? Why or why not? Why or why not? There's correct answers that you could say either way.
I think you could is just be a little bit messy because you have to make sure you're passing it. You're making a copy of it when you pass it instead of just passing the reference. And so that gets where it gets messy. You almost have to make a method for that and make sure you call that method.
Yeah.
But then just make sure you don't put any methods in it.
Yeah, so it's essentially whether you say yes or no, the answer, your rationale is going to be the same. You can say yes from the perspective of, yeah, so something that is very, very, very similar to a struct is created when you create a class and only decide to put fields in there, public fields, let's say. No constructor, no methods, even though you'll get a no argument constructor, just don't use it. This is the thing. But when you pass that struct to, when you pass that object to functions, it is passed by address by default in Java, where a struct is always passed by value. That's why we've been passing around struct pointers, the address to the structs, all right? Which gets even worse when we decide not to allocate new memory for our structs, and then we're just changing the original, which is beautiful but confusing, and I can blame it on age, and it works out. That's the thing. That's the old stuff thing, Annie. So I can blame it that I'm old, and I mean, just imagine Dr. Locklear. He just, he had a birthday yesterday. It's 107.
Wow.
Yeah, he doesn't look that young. It was on his Facebook page. You can like wish people happy birthday. My response was, did anybody see my response on there? I just said hashtag old.
I had a meeting yesterday where he brought a cake to it, and I didn't know it was his birthday.
Oh, he just randomly brought a cake to a meeting?
Yeah, it was Alpha Chi meeting.
Oh, he brought a cake for his own birthday?
We didn't know that's what it was for.
That's kind of sad. Next time you see him, you should tell him that. So.
Tell him hashtag old.
No. The fact that he brought a cake to a meeting for his own birthday.
I don't think that's the reason he brought it.
I think it might have been.
Think so?
Yeah. I mean, his Facebook page is called the Gary Locklear Fan Club. All right. So anyways, you can go with either answer here. But ultimately, the explanation is going to be the same. If you wanted to act like a struct, like you said, maybe use the clone function to give yourself a brand new version of this dude. So you're passing a copied memory, and now you can change it however you want, and it's still passed by address, but you're not breaking the original, or just don't change it. one of the two. All right. So questions about any of that? All right. So let's look at the stuff. All right. We're supposed to write our C-link list. And we're supposed to modify this guy for our to be able to hold exits or players, correct? That's the deal? All right, so I'm going to actually just copy all this stuff. I'm going to create a new file. Call this guy, save it. C generic linked list, something like that. .c. Have I been putting everything on the desktop in here? Do I change that tradition, or am I just going to confuse myself worse? The problem with AWS for this stuff in classes, we're just using standard C, so we don't need to worry about the sockets. It should just all work. Anything we're doing in here should work in AWS just fine. The second we start using networking sockets and things like that, that's when we definitely need to be over there because they might play differently. All right, so we'll just put it on the desktop like I've been doing. I'll go ahead and paste this stuff in here. All right, so now we want to go ahead and we want to update this dude to hold different kinds of values now. Okay, and we're bringing in clinklist.h, so I'm going to make a duplicate of that guy too. And this is where we've defined our node. So I'll copy that, new file, save. C generic linked list.h. Save that for right now. I'm going to close my C-linked list, the two C-linked lists, that way we won't confuse them. So now we have our generic ones. Okay. So inside of our .h, we want to update our node to no longer take in an int payload. It's now going to be a void pointer payload, right? So this is going to be the address of something, whatever that something is. All right. Remove end, remove front, get count, add end, add front. These guys are now going to be taking in void pointers. Now, why am I taking in void pointers here as opposed to maybe writing a couple of versions of this that either take in an exit struct or a player struct? I want this to work really. I mean, what we ultimately have is something that works for everything, right? So when we say I want to take in anything that's of type pointer, I'm saying hand me a memory address and I'll take care of the rest. You're not worried about the types at that point. Otherwise, you can kind of use the whole polymorphism idea, even though that doesn't exist technically in C. We would just have multiple, because it's not an object. Polymorphism is an object-oriented term. But you can have multiple functions that take in different parameters, although I don't think you can have two functions in C that each take in a struct. Because the parameter type, if you're having one take in a struct exit and another one takes in a struct player, I think C views those guys as both being functions that take in a single struct. So I think that it would not be able to differentiate from those two. Let's call it 87% sure that that's the case, but certainly something to check out. All right, so in any case, we'll update our node struct to now hold a payload that's a pointer to something. And we'll, for add end and add front, we'll take in a pointer to something. All right. So now we'll go back into our generic linked list here. And our head and tail, these guys can still be node pointers. No problem. All right, get count, still going to do the same thing it did before. Get front, still going to return the head. It'll be the value of head, which will be an actual node, right? Get end will return the value that lives at tail, which would be the actual node. Now here's remove end, which should also work the same way. That guy's going to traverse through, find the guy that lives at the end, ultimately get you to the tail and remap up things. The fact that we've changed what a node struct houses doesn't make a difference here, right? We've just updated pointers to these guys. So do we need to make any changes to remove end? Okay, what do we need to change? Because we currently have it returning the value that guy, which I think we decided the last time we can make the argument that we can make it return a struct. But in this case, we're saying we want it to return a value. Now, what kind of value do we return? Do we give it, I mean, our option here would be either have it return a value that we know is in there, or just have it return a pointer to the thing, and then let the person who called this guy figure out what that thing is. So we want to have this return a void pointer, this guy. So all our traversal stuff will work the same way as it worked before, except down here where we have our return payload, or here's our payload to return, where we're going to get tail, and this is the payload. This is our payload pointer. So this is no longer a int. This is now a void pointer. That's the kind of animal we're going to return now. might as well be called int. It's just, its stripes changed. It's now called void pointer. We'll do all the other same stuff. In the end, we'll return payload to return. Now, in our else, we had that that bailout. We want to go ahead and return null there for that guy, which actually makes this even a little bit better. Because before we were saying, hey, we'll give you a -1. It might be the real number, or it might not be. You roll the dice. Okay, so now we're going to actually give them a null value if for some reason we weren't able to return what they wanted us to return. All right, anything else I need to do for remove end? All right, so little change, just returning the kind of animal we're returning. Remove front, kind of the same thing. This guy's now going to return a void pointer. Here's our payload to return. It's now a void pointer. Goes and does all of its stuff. Same thing down here. We'll return null. All right, so now, is that it for remove front? Same thing we did for remove end. All right, now add end, these guys change a little bit. So first of all, we're no longer taking in an int payload. We're now taking in a void pointer payload. So this is always going to be a memory address, but that's not a big deal for us because now our struct is expecting us to give it a memory address. No big deal. Okay, so we'll do the same thing here. We'll call add front. We'll end up updating add front in a few minutes. Else, we'll create our node. We'll set our node's payload equal to the payload that was passed in. No harm, no foul. All this other stuff is the same. Pretty easy, right? So all we change is what the input was coming in, and since we just made that small modification to our struct, everything else is good. Now, let me ask you this. Why don't I say the address of payload here? Since I'm taking in a pointer payload, and I'm setting it equal to my struct's payload, why wouldn't I give it the address of that payload? What do you think? It's already an address. I'm expecting to hold an address. So I don't want the address of the payload variable. I want the address that payload holds, right? This guy here, at payload rather, or that's not at, right? That's and. Ampersand payload. This dude. I told you I'm missing a contact, but it is back in now. So it's like it's kind of like the shadow panes from like when you're missing an arm or something. We're actually doing some VR research on that. Like when people veterans when they've like
the commercial.
Yeah, so you're wearing these goggles and you can still feel like the phantom arm, so you'll actually see it in VR, and it helps get them over that thing where they don't have an arm there, but they still feel like they have an arm there because you're used to it because you had that arm for a couple of minutes, right? Yeah, it's kind of an interesting thing. I don't know if it'll turn into something really, really valuable, but those are all things that VR is good for like tricking the mind. And also, by the way, I think I put a link up that the Oculus Go is now out on Amazon. So talk to me in a year or so, and that yesterday was when it released. That's going to be a major, major turning point in mobile VR.
Why?
Because I think the killer app for VR is home entertainment. I mean, the things that made VR kind of cool up to this point are the games. And it's because it was designed for the gamers who already had the fancy computers with the nice graphics cards in it that could drive the hardware. They're the ones who are willing to pay the money for these expensive things. But you're not going to have VR in everybody's house. Like grandpa's not going to get VR to play Robo Recall. Most grandpas. But, I mean, people have entire rooms in their houses dedicated to home entertainment. You get a room that has a 60-inch TV in it, you watch all your sports there and things like that. And how much is a 60-inch TV? A good one can be anywhere between $1,000 and $2,500, depending on how good you go, right? A pretty big range. Now for $200, You can watch Netflix on a 100-foot screen from a broom closet. That's the example I always use. You don't need a room for this. And they already have these things that exist. How many of you watch sports? I think sports are kind of a big deal for this. So what if you could watch, let's use Packers as an example. What if you could watch a Packers game and maybe pick your 10 favorite seats in the stadium? And they put 360 cameras there. So you can watch the Packers game from the sideline. You can watch the Packers game from one of the end zones, the other end zone. Pick several different seats. Maybe they even maybe this would be more for a scrimmage type thing. I don't know how well tackles would work with this, but the Rodgers cam. So you see the game from the perspective of Aaron Rodgers. Okay, but now it's not just a video you're watching. You have this headset on where you can actually turn your head and see everything that his camera is seeing. Wouldn't that be kind of a cool thing? Mm-hmm. And these things already exist. There's already NBA games that you can watch from VR perspectives, but at this point they're kind of like test beds. Now that you have a device because effectively the Oculus Go is the Gear VR that requires this $1,000 phone to fit into. It's a great experience as long as you happen to get a really expensive Samsung phone. If you don't go Samsung, you're an iPhone user or you are a Pixel or whatever, then you're not going to have that access to that. The Oculus Go doesn't require the phone. It's a single device, you charge it just like a cell phone, it has all this stuff in it, that's the whole device. Put it on, you watch your live NBA games in VR. You watch your live football games in VR, hockey, whatever it is. That's what's going to change VRs now that you have virtual reality in a lot more households. Because consider this is day one. It's $200. 6 months, you're going to see sales for $150, for $129. Next year, you'll have $89 ones, whatever. So now it becomes something that everybody can have. As opposed to, an Oculus Rift, fine, it's cheaper, it's $400, but I need a $1,000 computer to drive it and all this other stuff. Now it's not something that just everyone's going to buy. That makes sense? So I think it's going to be a pretty big deal. I'll bring it in on Friday and show it to you.
You have it already?
Well, I have it ordered.
That's crazy.
Why?
I don't know. I just thought you said that it just came out yesterday.
Yeah.
You already have it ordered?
That's what Mike Littman does. If there's something cool technology-wise that comes out, I get it. Doesn't that seem pretty much the pattern? Yeah. It's like, what is this, amateur hour?
I'm just not used to that. That's all.
Man, tell you what, that's all I live for. Golf and that. Always got to have a toy, right?
Imagine playing golf with the Oculus Go, though.
Like you actually, those things would actually kind of make some cool sense for like a simulator. Mm-hmm. Where you actually you're swinging a real golf club. It gives almost like the augmented reality thing where you're seeing the actual ball that's by your feet, but instead of hitting you probably still hit the ball into a net, but you instead of looking at it on a screen like my simulator at home, I have a iPad Pro that's in front of me. So I hit the ball this way, and then I look at the iPad Pro and it shows me the ball flight and that kind of stuff, which is fine for playing golf in Wisconsin in January. But it would be cooler in VR. Except then you start getting into issues like with it getting sweaty and stuff like that. So there's all sorts of other things. But you're going to see this really grow over the next 10 years. And I think something like this, having a consumer level VR headset that's affordable, all in for $200 is something that needed to happen in order for something like, Ready Player One, for that kind of stuff to become the future. We can't rely on grandpa to go out and buy a gaming PC.
Wait, so this will run like the VR games on Steam?
This won't run VR games on Steam, but it runs Oculus Home. Okay. So it'll have a lot of mobile VR games.
That's like 1,000.
Huh?
1,000 and more in the library.
Yeah, but it's day one. Forget about that. All those things were made for Gear VR. You got to look it over what's going to happen the next 6 months or the next 3 months as people start writing stuff specifically for this device. Because now no longer are they targeting people who have this phone plugged into a Gear VR. Now they're targeting people who have the Xbox. Oculus Go is a platform in and of itself, and it has higher resolution than this one has for VR, but it also probably has the same processor as a Note 8.
Yeah, the performance a little better because it doesn't heat up as much.
And it's not trying to do all the other functions like phone stuff, right? But regardless, this is that starting point for that. And I think we're about a year out or so. Oculus is working on another product. I think it's called Santa Cruz is the name of the product. And this is kind of related to the inside-out technology you've seen with the Windows mixed reality stuff, where you don't need those sensors. So you just put the headset on, it has 2 cameras on it, and the headset sees your hand controls. So, but you still need to have that plugged into a real computer. Well, Oculus's Santa Cruz is effectively a headset that has 2 cameras, comes with hand controls just like real VR type stuff, doesn't need a computer, doesn't need sensors. It's all self-contained. So then fast forward another year, what's going to be next? What's going to be next? What's going to be next? And so this is the beginning of something I think really cool, but now you have that true first step where it's now something that could literally be in my dad's living room. He's sort of techie, but he's old. He would look at something like this and say, oh, that's cool, because he could watch his sports and stuff like that. He sits there in front of the TV all night anyways. Sometimes he's awake, sometimes he's not. But my mom sits there and chats on the phone, so this would be a way for him to just tune that out anyways. But the point is that this now makes this technology available to the masses, not just to the gamers. And I think that's the start of what makes VR become the next DVD player, the next Blu-ray player, the next, so on and so forth.
Do you think that we're almost, in a sense, the prequel to Ready Player One?
Well, absolutely. I think it's 100% certainty. I think that's just where things are going. This is no different than Star Trek, where you went back and watched things on Star Trek, and today we take those. They're not cool anymore because we have those. Same thing's going to be true with that. We just have to figure out how to solve some of the problems. How do you make virtual reality feel as close to real reality as possible when you start taking into consideration, when you're doing active stuff, sweating, running on a treadmill. So they have omnidirectional treadmills that actually exist today, but they're in prototype stuff. They're expensive. They're heavy. So this isn't something that Grandpa's going to have in his living room. Fast forward 4 or 5 years, it might be that you go to Best Buy and get an omnidirectional treadmill for using in VR. This is just how those things happen. You're going to have bodysuits that you actually feel. When you get shot in a first-person shooter game, you'll feel, at a hopefully lesser extent, the bullet. Like, just crank it up. I can take it. You got some guy recovering from his last FPS adventure. He's laying on his bed with these giant welts. It's like, what happened? It just wasn't my day. But, we joke about these things now, but these are going to be realities where you'll actually have to think about what pain thing do you tune your whatever to. It's going to be a thing. I doubt they'll have it at a setting where you actually feel the bullet. Okay? But there might be a thing where it's a little tack versus a thump where you whatever. But who knows? Before long, you won't even need the headset. You'll be a little thing you plug into your head and you go into some kind of VR coma thing, and now they effectively hijack your dreams. You don't have to worry about the other stuff. As long as you think you're running, you're running. Done. Wouldn't that be cool?
That sounds really
scary. Yeah. Let's assume that was the case today. Let's say they announced there was a beta test. Some company has, they figured that out, let's say, and they've tested it on whatever. Something that convinces you that it's at least possible. And they offered you, let's say a 3-month trial where you would go in and do that. You'd be one of their guinea pigs. Would you do it? Would you have would there be a number? What would they have to pay you to do it?
Just to hook me up to...
Hook you up. They're going to have you under medical supervision. And you are completely in a virtual world. As far as you're concerned, it's the real world because they're hijacking your brain effectively. And you're out for 3 months. And somebody else is making sure you're fed heavy on IVs and crap like that. So you're not going to die. Well, unless there's a bug in the technology. But the plan is you're not going to die.
There's always a bug.
So there's always a bug.
This sounds like an episode of Black Mirror.
It does.
Yeah. Well, it's also a lot of books already have this kind of storyline in it, with the whole going under VR type thing. None of you would sign up for it?
How selective is it?
What do you mean, how selective?
Like, how many other people are getting to do Honestly, I think I'd be more inclined to do it if less other people got to do it.
So if you were like the one special one.
Yeah, oh yeah.
Let's say maximum of 3, between 1 and 3. Either you're the only one or you're one of 3.
Yeah, I won't have to relate to other people. So yeah, 3's the
Yeah.
sweet spot, I feel like.
Wow.
So you would do it today?
Probably. Same.
Yes.
Yeah, so would I. In fact, if they walked through the door right now, I'd probably just do it. I wouldn't even check with my wife.
Here's Sean.
Annie, you're going to have to break the news to her. I'll leave my phone here. You can just text her. It's like, yeah, Mrs. Lippman, your husband's gone for 3 months. Like, what happened? They just hauled him off. He's in a coma. Like, what? What happened? No. He chose. So VR coma.
This is on him. My hands are tied.
Well, then you have a phone you can eBay. By the time I come out, there's going to be a new phone, better phone. This is new. This is like a, yeah. I'm using my iPhone, last year's iPhone 7 Plus. I use that for a soap dish. I have that in my shower. I put soap on it. Yeah, it's a nice little surface because it has the ledges on it so it doesn't slide off.
Oh my God.
It's probably the best use for it.
Yeah, seriously.
I still got my 5C.
Oh, man, 5C. Well, first of all, that's too small to be a soap dish.
Barely running.
You have to use that like at the hotels for like the little baby soaps they give you. Right? You can't use it for like full-size soaps. I guess you can use a 5C for like, one of those things that you like use to like scrape pans, like the dried pasta off the bottom or something like that, because they have the kind of the metal edge on it. That might work. Oh, so good. All right. So add in, we get our boiler. How do we go over? I'm the king of weird tangents. I've been doing this for 20 years. Okay, so we're taking in a void pointer. When we build our struct, we're setting it to a void pointer. We decided we don't need the address of payload because that would give us the address where the variable payload lives, not the address that payload holds. That make sense? Understand the difference between those two? Ampersand payload, we have a variable called payload. And that variable lives somewhere. It also happens to hold an address. If I say ampersand payload, I'm saying, give me the address where this dude lives in memory. When I don't say that, I'm saying, give me the value that lives inside of this guy. And the value that lives inside of that guy is an address. What if I said star payload? What is that guy? Yeah, the actual struct. That is the value that lives at the address that's stored inside of payload. Because this says resolve payload, which is going to be a memory address, the memory address that payload contains. And then this says go to that memory address and give me the value that lives there. Make sense? See the difference between those three things? All right, but in this case, our payload is our address where the struct lives. That's what we're going to set our struct's payload equal to. Okay? Because he is a void pointer. That's exactly what I need for this guy. Okay. That's good. Rest of that looks good to me. Thumbs up. Add front. Also going to take in a void pointer payload. Also going to just take the payload, blah, 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 blah. Rest of it looks good. I think that's the homework assignment. Except now we have a linked list that can't just hold exits and players. Now I have a linked list that can hold anything. Right? Anything that can have a memory address, which is everything in a computer. That's actually more powerful than we can pull off in Java. Remember something I said when we first started learning about, probably in 200 or 250, wherever I introduced it, I probably talked about it in both. Kind of the evolution of our languages. We went from C to C++ because, we kind of saw the weaknesses of just having structs. We needed objects, and we went from C++ to Java. And, C++ empowered programmers to make bad decisions because you had so much control over memory. Well, when that went out the window, And when we threw the idea of directly controlling memory out the window, now we lost the ability to have pointers that go to primitive types as well as pointers that go to object types. I mean, in C, we didn't have object types, so everything was effectively a primitive type. Structs, ints, chars, they're all the same thing, right? So really, in order to have anything passed by address in C, we had to have the syntax. In C++, an object by default is passed by address. So we'd have but we also had the syntax to make some decisions. We could pass the value of the object by passing star, whatever. Well, when we got to Java, we lost our special words, right? We lost the ability to dictate whether we wanted this to be the address of something or the value at something, and it just was whatever Java thought it needed to be. So we talked last time that we had a situation in Java where if we wanted to make a generic linked list, we would have, well, actually, let's think about that. How would we make a truly generic linked list like this in Java?
Using those generic types things?
Yeah, you probably could pull it off with generic types, but even then. Yeah, you could pull it off with generic types. You'd have a link, actually you wouldn't even need that. You could have a linked list of objects. When you put stuff into the linked list, they would come in as a generic object. But you would have to wrap ints and chars and those guys, you'd have to wrap them in their equivalent objects. You'd have to, any other object could go in because everything is an object in Java. Okay? But you couldn't just put the address of an int in there. You'd instead have to wrap it in an integer object in order to get something that holds the address of a integer. Does that make sense? So if I'm out
Why do you say wrap it?
here, I'll show you. Just do this. Oh. All right, so let's say I have an int a is equal to 5, and then I have an integer b is equal to new integer a. If I say system.out.println a, I'll get a 5. If I say system.out.println b, unless they overwrote the toString, I expect to get the memory address of the integer. Oh. Oh, they did overwrite the two things, so I need to do this. This is still going to break. Here, I think I can do this. No, it's still going to break because B will hold the address of my integer object A. When I do system.out.println B, it's actually calling B's toString, which will hit integers toString before it hits objects toString. So objects toString is the one that prints out the memory address. So this is just more of a convenience of Java instead of, I mean, what I said is still accurate. Just the integer.
It's just the print.
Yeah, the integer object has implemented a toString method that gets the integer value that's in there, rather than showing you objects version of toString, which shows the memory addressy looking thing. All right, so we could really, when I talk about this, the difference here is if I pass a into a function. In fact, let me do that here. So let's just do void change int. This guy will take in an int a. We'll say a is equal to 7. And then we say void change integer. It's going to takes an integer a. Let me look real quick if we have a thing to set the integer for an integer. I would think we'd have something like set int. We have something that returns it. Killing me. Nope, once it's built, it looks like it's built. And I can't set it to a different pointer because then it would be a different memory address and wouldn't, yeah. So I really can't show you the example with this particular one just because of the way it works. But, you know, the idea would be if I could change the contents of A inside of here, when this function was done and I went out and printed out A here, it would be the new contents. Well, actually, I'm printing out B. So I would pass B into this function. If I changed it in here, and then I went back here and I printed out B, B would show the change. If I passed A into this function, and I change it here, then when we came back here to main and I printed out A, it would be the original value. Because ints are passed by value, objects are passed by address. Make sense? All right, so in any case, that is the working code dealy flippy. Make sure you get your homework turned in sometime today. Sorry I was late putting that up. And I will also make sure you look at Slack. The senior seminar presentations are next week. I'm doing 1% extra credit per presentation you attend on your final exam, which then would go to your midterm if you end up replacing your midterm with your final. So if your grade isn't what you want it to be in here, I strongly encourage you to attend as many of those as possible. That's next Tuesday night, 5 to 8, next Thursday night, 5 to 8. Go on Slack, you'll see all the presentations, the order, and what the kind of the little gist of what they're doing is. I will see everybody on Friday.